So this problem states that an airplane is flying 30 miles per second, or 30 meters per second to the west. Now it says it's flying into a region where the air is blowing 30 degrees south of west, 10 meters per second. So we want to find the velocity of the plane to the ground. So we know right here that since it's going this way, then that is the velocity of the plane to the air. And then the wind blowing this way is the velocity of the air to the ground. So to find the velocity of the plane to the ground, we need to take the velocity of the plane to the air plus the velocity of the air to the ground and add those together. So the way we do that is that we find out what the velocity of the plane to the air, the x-axis is, which is negative 30 meters per second because this is negative on the x-axis. Now for the y, we know it's going to be 0 because it's only traveling on the x-axis and there's no y that it's traveling on. So for the x-axis for the velocity for the air to the ground, we know that it's going negative 10 meters per second cosine 30 degrees. The way we find this is that we take this 30 degrees, we know that this is 10, so we know cosine is adjacent over hypotenuse, and we rearrange that to where we get negative 10 meters per second cosine 30. And that gives us negative 8.66 meters per second. Now we do the same thing with y, which gives us sine, and that is opposite over hypotenuse. So we do that and we get negative 10 meters per second sine 30 equals negative 5 meters per second. And we know the hypotenuse is the 10 meters, so that's how we get that if you're wondering. And then we need to add those together. Well, just like other things, with the relative velocity, we add it up by the axis. So the plane to the ground x would equal negative 30 meters per second plus negative 8.66 meters per second equals negative 38.66 meters per second. And the way we did that is that we took the negative 30 that we got from the x-axis for plane relative to the air, and then we got the air to the ground, x, which is negative 8.66 meters per second that we found. Now we do the same thing for y. We know over here the y was 0 for meters per second for the plane relative to the air, and we know that the negative 5 meters per second is air to the ground on the y. And we got that because of the trig that we did right here in rearranging it. So from what there, we need to add them to find the, I guess you could say, not the magnitude, but the, I guess, because it's a right triangle, so you take them in and you go negative 38.66 meters per second squared plus negative 5 meters per second squared equals 39 meters per second. And the reason we do that is Pythagorean theorem, I'm mispronouncing that, but just like we do with all the other velocity problems, and you add those together, square them, and you get 39 meters per second. And that's how fast it would be if the pilot does not change the heading of the plane, meaning he keeps continuing, then he would be traveling at 39 meters per second relative to the ground. For the part B of the problem, it says, what will be the new course relative to the ground? Now they're asking how far is the wind going to be pushing us? Well, if you know how to find angles, it's relatively simple after that. It's tan inverse gives you the theta. So we just say, okay, well, negative 5 meters per second over the negative 38.66 meters per second, and the negatives are going to divide into a positive, and that's going to come out to be 7.4 degrees south of west. So the plane's flying like this, and because this 10 meters per second wind is flying at 30 degrees, it's going to push his plane 7.4 degrees south of west. And that's the problem.